trying to get another screen so I can see some of the questions here. Versioning comes up in the architecture piece, but let's do this. I have some extra content on versioning that I did not include in this particular presentation because we're cutting it short. I'll make that available as well too. But I think in a nutshell, you need to version this stuff from the start. The mistake I see customers make is when they say, hey, we're going to build out a distributed application, we're going to build microservices, and now we're even in production, and guess what? Well, we really haven't thought about versioning, but now we have to version. And so now we have to retroactively fit that in. And that becomes really tricky to do, not only for you, but for your customers as well, too. So I think it's really important to say, the contract that we come up with that basically exposes the service has to be really well thought out. And then the versioning has to be in there from the very, very beginning. And then if you think about it, we're versioning each service separately. So that becomes a lot more challenging to manage as well, too. When you're versioning, you can version service. If you have a REST service, you can version it a number of different ways. You can version it in the URI. You can version it as a query string. You can version it in a header. Different ways of doing that. So that again, really, and there are pluses and minuses for each. For example, Azure, if you look how they version, pretty much is going to be in the actual request header. Many sites they'll use in their actual URL. You'll see like a V1 or a V2. Sometimes with service providers, you'll see at the very end they'll have a question mark in the URL, and they'll have a set of query string parameters, and one will be the version. So really, there's pluses and minuses for each. We can send you some content about that as well.
Fantastic. All right. We've got some folks asking about format of the event here. We'll keep those over there in chat. We don't need to discuss them out loud. Why .NET Core? Why should .NET Core be considered for more use in larger companies instead of Ruby, Golang, or Node? Well, gosh, Rob, I hear that type of question and I think about, and I think use what works best. These all work. All these technologies work very well. This is an architecture pattern we're talking about.
Correct. I agree completely. So, it's not really about the technology. It's about understanding the patterns, the best practices, the principles, and applying them accordingly. I think people who have a strong .NET Core background or certainly want to work in Core. I think people in other languages like Ruby, like Go, for example, may want to do Go. I would say that .NET itself, is a very mature language. It's been around for a long time there, but the productivity is just, I think, really, really big. When I spent time writing the Cloud Native book, I looked a lot at Go. Love Go. I think it's really, really cool. Looked a lot at Java, but I'd have to say that I think one of the major things that I love about .NET Core is just your productivity tools. There's a lot that gets done for you. You have to understand things, but again, in terms of getting things done fast, there's a lot of nice tooling and a lot of nice abstraction, a lot of nice things built, I think, into .NET Core to make things well. And again, if you look at it now, when we talk to customers now, what I typically see is this pretty much. They're building out microservice applications. They're using .NET Core, but they're basically they're hosting those applications in Linux containers running in the cloud in an orchestrator, like say Azure Kubernetes services. So again, even though they're doing .NET Core, they're actually hosting it, in Linux. And again, the nice thing about .NET Core is it really is cross-platform. You build your code, and basically we have runtimes for Windows, runtimes for Linux, and most of the major distros are included for Linux, as well as you can even run it on OS X as well. So again, it really is truly cross-platform. I think a lot of people sometimes don't realize that. They're coming from Microsoft saying, well, I remember .NET framework, from 2014 and 2012, and it was all Windows, but they just haven't taken the time to look at .NET Core. And when they do, I think what they're going to see is, my gosh, this really has changed and is very open.
Yeah. There's a question here about do we have an example that uses SQL Server for the event store that we can take a look at later today?
We're using for the event store, we use Azure Service Bus, but what I will show you is that we've abstracted out the event store pretty much say we can plug anything that we want into it. So in other words, we can say, hey, I want to send, I want to send events back and forth. I want to do a pub sub. And we'll show this in a little bit. So we built out an event bus abstraction, which basically which the application will always talk to, and then for the abstraction we can plug in. We can plug in Azure Service Bus. We can plug in Azure Event Grid. We could plug in RabbitMQ. We could probably write a provider. We could plug in SQL Server as well too, if we really wanted to. But I think if you're doing eventing, you probably want to look at an eventing service. Something that's basically built to handle that pub sub relationship. And again, when you're looking if you're looking at Azure Service Bus is just a very mature message broker to do that. It has all transactions, it has partitioning, it has all kinds of things in there to really make your life easy.
Good. All right. There's a question here from Wesley. Let me see if I can put Wesley's question up on the screen.
Sure.
Where'd it go? There we go. Would you say containers and orchestrators are a best practice for microservices? Is anybody doing microservices without those technologies?
That's a great, from my experience, and we work with a lot of customers who are either looking at doing this or are doing that. So like our role pretty much is to come in and help enable them or come in and help optimize what they're already doing. And they're almost always they're almost always containerizing their microservices and deploying them in an orchestrator. If you think about it, if you have 10, 15, 20, 30, 50 services, you really can't manage that very efficiently manually. That needs to be automated. And like we'll see this afternoon when Monica comes back and talks about AKS and about containerizing and orchestrating, you'll see the magic there. So again, these tools are able to, these orchestration tools are able to basically take those containerized microservices, provision them, and basically manage them, in terms of scaling, in terms of health, in terms of deployments. So I would say that, it's very unusual, at least in my experience, to see people not trying to containerize and orchestrate their microservices. You almost have to at a certain point because managing them manually just isn't feasible.
Yeah, right. Once you get to scale, once you get to all these different things that are going to be involved with your applications, now it becomes the maintenance challenge. Oh my God!
It is. And again, like we said in the beginning, everything really needs to be automated. You need to have infrastructure as code that can. You need to run basically a script that will build out your infrastructure. So if you're running in the cloud, which is very common, you can't really be in the Azure portal saying create a brand new service bus and we're going to call it this and we're going to use this plan and put it in this location. No, there needs to be, everything just needs to be scripted out so that I can pull that script out of source control. I can plug in the parameters for the current instance and run that script. That needs to be automated. Then all the code deployment, everything we do, we need to have a set of pipelines. Typically, it's one pipeline per service. And then, so that automates our code deployment, our builds and deployments. And then what we got to do too is we need to say, when we're running these things in the cloud, we really need to have an orchestrator doing that for us. Again, the orchestrator, like we see this afternoon, it does a great job of managing the actual deployment and managing the services in production. That's a must-have, because trying to do that stuff manually is just not going to be a good story for you.
Okay. There's a question here from YCA Bello. What about having serverless Azure function-based microservices with ARM templates?
Yeah, and I think it's a good suggestion. And we are seeing more and more people looking at, hey, can I either write my application, my microservice-based application, using the Azure Function Framework, or at best, or at the least, are there some services that I can expose as Azure Functions that may make more sense than making every one of my services an API out there? So again, absolutely yes. And my guess would be as time goes forward, we'll see more and more and more services in general built as serverless Azure-less functions. I think the industry is going that way. We see that both on our side, and I think we see that a lot too. If you look at our competitors, we're seeing the same behavior there as well. So again, functions, Lambda, all of that's just, that I believe is up and coming. And again, I think customers love the serverless piece because again, they can deploy this stuff and not have to get engaged and involved and manage provisioning and managing server aspects of it.
We have Manu here. Let me see if I can get him back into the
Perfect.
discussion. There we go. Manu, can you hear us?
Hi, Jeff.
There we
Can you
go.
hear me?
Yes.
Oh, awesome. No, I completely agree, and I was just gonna kind of chime in. If you think about cloud native architecture, obviously stands on two core pillars. So there's microservices, and then there's containers, along with, as Rob mentioned, automation, your automated pipelines, etc. So microservices obviously kind of fit well with containers. They kind of complement each other because if you think about microservices, as Rob has explained, you do one thing and you do it well, and the premise behind containers is very similar. You kind of run typically a service process, an application service process within a container. Now, having said that, obviously, if you want to do microservices without containers, you can still do that. I mean, still have a platform, Service Fabric, which customers have used or are still using it, where you can kind of deploy microservices on. But I guess the more conventional wisdom now is to kind of break these monoliths into microservices and then obviously deploy them on these kind of lightweight containers, because with agility, you get portability, you get better debugging capabilities, and some of the other capabilities which Rob talked about. So that's kind of the pattern. With most of our customers, when they talk about, hey, I want to modernize, your cloud native architecture, or maybe cloud optimized because they may not be ready for a full-fledged native architecture yet, they do kind of consider containers, right, before anything, because that helps them with portability. But at some point, they may start breaking down into microservices, and then it kind of becomes an easier journey because they already have container infrastructure set up, whether it's on-prem or in the cloud. So yeah, Rob, over to you.
Yeah, and can you guys hear me okay?
Sure can.
Hey,
Yes.
and I'd like to add into that too. That's a really good point. And keep in mind, we're talking about containers and we're talking about orchestration, really two different things. So container writing is taking the application, like we saw yesterday in many of the presentations, building out this binary distributable that inside of it has all of the code that you need to run, as well as all the dependencies, the runtime, everything in it. That's phase one. Phase two then is taking that container and then using the orchestrator to grab that container image, schedule it, which means basically deploy it out to various different nodes and manage it. So again, those are two different things, but they're very, very critical. We have some, I think, nice tooling coming down to pike. We saw yesterday, Shane Blair showed a little bit too. We're able pretty much to say, even though you're working on an application with a large team of people, you have 30 microservices, you can't have all 30 microservices on your laptop. That's not going to work well. So maybe you have your own microservice, right? But then the question becomes, well, then how do I run it? How do I integrate that? How do I make it? Because I don't want to, otherwise then I have to write a bunch of mocks, right? Just every time I'm going to anything external, we need to mock it out. But with some of the tooling that we have, the Azure Dev Spaces and some of the evolution of it allows you to have a development instance of the application running in Azure Kubernetes service. And you can basically say, I have my service on my laptop, I am hooked into that development instance running. So everything's running in AKS, okay, But when it comes to my service, it's really accessing the service on my laptop. So you get sort of the best of both worlds. And that's going to be something that's really important because, again, you can't, like we said, you can't have 20, 30, 50 different microservices on your laptop. So, and I think we're seeing Microsoft really think about and go down a path of trying to solve some of those, I'll call them thorny problems with them. So again, I think that makes it a good platform for building microservices. I think a lot of our tooling is available not only for .NET Core, but I think the combination of Core along with all the tooling that we're looking at, things like Thai, things like Dapper, things like DevSpaces, really give a nice end-to-end story. And you're going to need that because when you get into microservices, again, there's many, you have many moving parts.
Very cool. All right. What do you say we get back into the next module here?
Perfect. Hey, everybody. So we have limited time. So here's what I'm going to do. We have a module here called modeling microservices. I'm just going to skim it really quickly. We'll give you the content, but just be aware of this because I want to move along into some of the architectural and communication concerns because I think those are probably more critical. But I just want you to be aware. So I'm going to give you the 30-second overview here. Again, when you're dealing, before you write any code with your microservice, right, you're going to really want to think about how do I model these things. So you have a greenfield application, brand new. There's a process you have to go through in really being able to depose that greenfield that problem domain that you want. There's a lot to it. Then you begin to move into some of the more common domain-driven design practices. Julia Lehrman talked about this yesterday. There's one called a bounded context. Very popular design when you're dealing with microservices or distributed applications. It's a pattern for basically dividing these large domains, these problem domains, into logical subsets. So there's a lot to it. Again, keep in mind that you need to go through these exercises because, again, if you just start coding without really spending the time doing your decomposition, you're going to probably end up in a scenario where you're just refactoring all the time, over and over again. So there's a lot of thought being, I think the harder part on this is really beginning to say, here's my problem domain. Maybe, our problem domain is we need to expose an online store. Okay, great. What are the different subdomains in my online store? What adds value, right? And these contexts, these end up evolving into microservices. So again, there's a lot of upfront thought. It's not a good idea, I don't think, just to start coding this stuff. You need to spend time really understanding if we have a problem domain, how do we break it up? What makes sense? So again, we'll include the slide decks, and I hate to gloss over it, but I want to get into more of the architectural stuff with this. One more thought on this too. So when you're dealing with microservices, you can be looking at greenfield applications. A lot of our customers now, they're saying, hey, we have existing brownfield, legacy monolithic apps, actually be able to do something with them, okay? We have this application, it's critical to the business, it drives the business, but you know what? It's just a nightmare to deal with. We're in our fear cycle with it, right? It's sucking up all our budget, it's not agile. So there are a number of steps, practices, patterns to begin to think about taking a brownfield application as well too, and beginning to iterate through that and transform. I'm going to use the term re-platform, not refactor, but re-platform application from a monolith, step by step by step, service by service by service, if you will, into a microservice application. And I think Brendan Burns had a really good point. If you take an existing monolith application and you begin to break it up and iterate through it, you're moving modules into services, keep in mind sometimes that you don't always end up fully, with a full microservice application. It's very common for a customer to say we have a brownfield application. We've gone through our analysis. We've identified how we're going to break it up, and we're going to break off the pieces that are critical to the business, things that change a lot, or maybe things that are just running slowly, our performance issues, and we're going to service enable those things. Why? Because if I service enable what changes a lot, I can push that out individually or separately from the monolith itself. And I can have everything working together. And sometimes what happens is a customer, they'll go through many iterations of moving functionality from their monolith to individual services. And they'll get to a point where they'll have a hybrid. They'll say we have the things that change a lot or that were problematic, okay, or need to scale separately in microservices, and everything else is in the monolith, and it's working together. Maybe we stop now because we're at a good point. Everything's working well, so we have to maintain this monolith, but it may not make sense to take all of it in microservice enablement. So there's a lot to, again, modeling microservice applications, whether they're greenfield or brownfield. We'll include the slides. Please reach out with questions. Again, we have an engagement with our with Microsoft customers. It's becoming more popular, and that really is the brownfield replatforming, going in and trying to help them understand how can they take an existing application and break it up into a microservices application. Okay, let's keep going. I'm going to get into some code now. We've been talking a lot. So we're developers, a lot of us. So let's talk about architecting microservices. This is pretty much right here the reference architecture that we have, that we're going to look at. We've got this code. We'll make it available to you as well, too. It is, if you've seen the eShop on Containers application, it looks quite a bit like it. Our original thought was to sort of make an eShop light, because we think eShop is a masterpiece. I mean, it is a reference application or architecture that you can go to on GitHub, download. It's just beautifully done. There's so much in there. But it is a bit complex if you're starting out. So we ended up sort of with the eShop Lite, if you will. So it looks a lot like it. And over time, it's evolved as well, too. Looks like this. We have a front-end .NET Core MVC application. We have something called a gateway. We'll talk about that. This is a service that's just in the middle that basically routes all the incoming traffic to the back-end core services. We have 3 back-end core services. We have a catalog service, which is basically responsible for rendering or showing you all the items we sell. We have a shopping basket service. Obviously, that's to manage your shopping basket for things you want to buy. And we also have an ordering microservice as well, which is when you create an order, we go through here. You can see the lay of the land here pretty much. We have something called an event bus as well, too. We'll talk about that in the next module. This is where we can send asynchronous messages from one service to another. So we'll talk a lot about that, but this is what it looks like here. Let's talk, and if we look at the code really quickly, and we'll get into the code a little bit. Here's the code for it right here. I am going to zoom in just a little bit. You can see we have what we got going on here. We have a bunch of folders. The gateway code lives here. All of the services, the shopping basket, the ordering, everything lives there. The UI code lives here. We've got a set of building blocks. We'll look at this in a little while here. These are things that help us. These are things like our event bus, our command bus. We've got a lot of helpful things as well, too, in here that we use. The services, as you can see, we've got, we're actually expanding this thing out. So now we have 5 services, 5 backend core services, where the basket, the catalog, and the ordering are going to be the key ones. We're currently working on bringing the payment and the shipping into the application as well, too. So you can see pretty much when this thing runs, we're running the gateway, 1, the basket 2, the catalog 3, the ordering 4, the payment 5, the shipping 6, and the UI 7. We're running 7 different processes at one time. So again, that's kind of, if you're running this on your laptop, that's kind of pushing the cart a little bit, even on a larger laptop. But it still works. Let's talk about service design, though. And again, I think Julia Lerman touched upon this yesterday. I want to go a little more into it. So service design becomes really important. So again, if I'm going to build a service, how am I going to design it? And I got a couple of choices here. So I could do this. Like I said, I'm going to build a service. It's a relatively simple service. I might put the entire service into a single assembly. So I'm not going to physically layer it. I'm not going to have maybe an API assembly on front, which has my API controllers. I'm not going to have a business domain assembly and a data assembly. I'm going to basically put it all into a single assembly. I'm going to layer it. So within my assembly, I'm going to have a more of a front-end application layer with the controllers. I'll have a domain model layer with my domain logic and an infrastructure layer, but everything runs together. Because again, you'll see a lot of times customers will say, hey, you know what? You look at my service. It's a very simple service, but you know what? I've got a separate assembly, for the controller, for the API controllers. I got a separate assembly for the business logic, a separate assembly for the data logic, or data access logic, and that's fine, but all they're doing is just passing through each other. There's no real business logic. So I'm kind of at a point now. I attended a class with somebody named Udi Dahan, who, by the way, is like the king of services. He's the ultimate, right? Great class. I recommend anybody going to that. But his idea, too, was if you don't need it, don't do it. Keep things simple now. If I don't need a separate assembly for my domain logic and a separate assembly for my infrastructure layer, just put it all in one. If later on you have a good, solid architectural reason to do that, then we can begin to break it up. But again, don't make things complicated when they don't have to be complicated. Keep things simple. So, for example, our shopping basket and our product catalog service have just a single assembly for each. Everything's inside. And then what we're using, and Julia mentioned this yesterday, we're using something called the anemic domain model. Now, there's a good chance you may have never heard of that before, okay? But there's a good chance you've been building anemic domain models for a long time. I wasn't even aware of what it was until I really started to look at microservices and at distributed architecture. But again, in our application, both the basket, shopping basket, and catalog both implement an anemic domain model. It is a common procedural design with the following characteristics. You typically have one or maybe a very small number of business service classes that contain all your business behavior, all the rules, all the logic, so your methods are all in that class. And then you have typically a large number of very small entity classes that only contain state in there. And when we look at the state, each property is going to have a public setter and a public header. So again, here's my business services class. This could be this is my product class, public product class has an ID, a name, a manufacturer, so on and so forth. Maybe I have an artist class, I have a genre class, simple data classes, and again and they basically get consumed by this business services class. So here's an example. Let's look at it. So if we go into our application here, let's go into the catalog. You can see one assembly, catalog API. We do have it nicely layered. You can see in here we have, a controllers layer. We have a contracts layer. We've got some commands we'll talk about later in here, some events. But again, if we go into the domain folder here, this is where the business logic lives here. And check it out. We have a folder called Business Services, which has this catalog business services class, and then a folder called Entities, if I can open that up. And again, the entities have just very simple, data only, state only entity classes. Here, for example, is a product entity class. As you might guess, it's just state. A product has an ID. A product has a title property, a correlation ID property, a reference to artist and genre, but these are all, and notice each property has a public getter and a public setter. So I can basically set anything I want to the price, anything I want to the title. There's no, in the product class itself, there's no validation in here, so I need to be careful with that. So I have, again, a product class, I have a simple genre class, a state class, I got a simple artist class. Remember, we're selling music. So, a song is a product, has an artist. An artist, a song has a genre. It's rock, it's jazz, so on and so forth. A song has a distributor, so on and so forth. And look at this here. Then we have this catalog business services class, and this class has all of the business logic in here. So you can see pretty much here's a get all music method. Here is a music to get a single song by ID, get top selling music, get all the genres, get a single genre, get the artists. Here's one to add a brand new song, update a current song, so forth and so on and so forth. Notice a lot of these, though. What do you see here? There's not a lot of business logic here. These are pass-throughs. So we're going through the business logic. So we're coming into the business domain, and what are we doing? We're calling the data. We're calling our data objects here. So again, this is pretty common here. And this is probably okay because again, we don't have a lot of business logic in our catalog service. It's pretty much a simple CRUD service, okay? You know, create, read, update, delete service. So again, this is what a typical, this is what an anemic domain model will look like pretty much. Now, you might have more than one. You might have another business services class, well, too, where we're splitting up. But again, all the logic for the business, all business logic is separated from the actual data itself in here. So again, this works fine. I mean, there's nothing inherently wrong with this, but there are some considerations about it, right? Again, look at this here. Seductively simple to implement. It's not hard to build an anemic domain model. But here's the problem with it. It tends to scatter business functionality across multiple classes. So again, I have behavior here. I've got data over there. And again, so we need to be careful with this here as well too. And then with my data, my data classes have public getters and setters. So I need to have the validation for that data in my business class. I need to make sure it's there. I don't want to be putting invalid prices or invalid names or invalid values into my data class. And again, I can do that because I got a public setter. I can put anything I want in that class pretty much, right? The problem with this is over time, this particular model can become difficult to understand, difficult to test, difficult to maintain. Because if this is changing a lot, what you're going to find over time is you're going to be running into problems where it's going to be harder to sort of differentiate exactly what's going on here. And again, this often tends to foster duplication. So you might look at a anemic domain model like we saw and consider it appropriate for a simple service. So have a simple service, more of a CRUD service. There's not a lot of business logic. It's not changing a lot. That's probably perfectly fine. But if I do have a large amount of business logic and or that business logic is changing frequently, this may not be the best pattern for that. Over time, this is going to end up getting messy again. So we saw the anemic domain model. What about this? What about using more of a domain-driven design approach, right? So if I have a service that is complex, and most services are complex, and most services will have a lot of complex business logic, or if it's changing a lot as well too, I might want to think about isolating my concerns, right? First of all, I might do this. I might say I'm going to have a separate assembly in this case for all of my front-end application logic, my API controllers and that. I'm going to have maybe a separate assembly for my domain logic and a separate assembly for my infrastructure. I may at this point begin to separate those physically because again, they're more complicated and I may end up at some point in time wanting to unplug and plug other things in as well too. So again, I may want to separate these physically, but I also may want to look at a couple of domain-driven design patterns. One would be called the domain entity pattern. So in this case, what I want to do is I want to have an entity class for each particular entity in my application. So remember we had a product class, we had a genre class, we had an artist class, and then we had this business class. We have a business logic. I may turn that around here. I may say, I have an order entity class here that represents not only the state of that order, but all of the business logic. So I'm going to say I'm going to do away with that business logic class, and in each entity class, I'm going to include the state for that entity and all of its business and all of the logic inside of it. So everything order goes in order. If I have maybe here, I have a customer. I may have a buyer class as well too. The buyer class consists of two things. All of my state is in here and all of my business logic. So everything buyer is in my buyer class, everything order is in my order class. I don't have separate business classes or separate state data classes, if you will. Everything is together in one. There's a one-stop shop, if you will, for each one of these entities. Each one contains the business logic, the state, the rules, relationships, everything is inside the entity class, right? This works really well, again, or we have complex business logic in our services, or we have logic that changes frequently as well too. This helps us improve maintainability, testability. It helps enforce data integrity. Again, everything is contained within that class pretty much. Again, a better choice probably for most complex services, but developers do need to understand some basic domain-driven design principles for this. And as well, and again, I keep referring back to Julia Lehrman. She talked about domain-driven design yesterday, and she has some very good articles about it. In fact, she and Steve Smith, if you go out to Pluralsight, have a lot of good stuff about domain-driven design. The other pattern that we see a lot is called the domain aggregate pattern. Again, what does that pretty much mean? That pretty much means that we take all of the related entities and we group them together into something called an aggregate. So here's an order aggregate. Again, this is a logical container, if you will, that contains the order class and the order detail class. We might have maybe an order category class and some other classes that pertain to order. These would all live within, again, this order aggregate class. So everything order lives within the aggregate. So again, we're containing or putting together all of that. So each aggregate, again, is self-contained. We're encapsulating everything inside of it. And then what we do is we say, you know what, within this aggregate, one and only one of those entity classes becomes the root. You'll see here the aggregate root. And again, all of the other classes, the order detail, the order category, all of those other classes, those become the children of the root. Oops, sorry, I went too far on that. So what's good about that then is pretty much anytime we want to reference an order, we always go through the root. So if I need some information about order detail in this particular scenario, I'm not going to talk to order details separately. I'm going to go in through the aggregate root. It is going to expose members not only for itself, but it will also expose members for the children. So if I need to know how many products are in a certain order, I'm not going to call order detail. I'm going to call into the order class, the order entity itself. It will have members that will basically then call in on my behalf into order detail and then get me that particular number. So the root exposes members that access both the root and the children. We go back to here. We typically don't reference the children entity directly. We go through the root for that. So again, the aggregate acts as a single unit and it implements this functional boundary, in this case, around everything order, if you will. It guarantees consistency at the root level, and again, it implicitly forbids external objects from holding references to its internal members, if you will. So again, very common practice that we see in here. We can see that in our ordering service. So if we go back to the application, let's close the catalog. If we go down to ordering, you'll see in our ordering domain, notice again here too, like we said, we have, let's take a look here. We have in ordering, we have physically separated out the different tiers. There's my API tier. Here's my ordering domain tier. Notice I've got two data stores. We'll talk about this in a little while. I've got a NoSQL store and a relational store. I'm implementing CQRS, where my reads go through against the NoSQL and my writes go against a relational database in this case. If we go into the ordering domain, you'll see here we do have a folder called aggregate models. Look at order aggregate, you can pretty much see I've got four order classes. Let's do this, it'll be better. I've got 4 order classes in my order aggregate. I've got a status, a detail, and an order. The order itself is going to be the root for my order aggregate. So it will contain, if we go into order, it will contain methods or endpoints or operations that apply not only to itself, but also to things like line item count, so on and so forth in here. And notice again, one thing that's interesting about this as well, and I think Julia pointed this out as well, notice in my order class, here are the actual property references. Notice that I've got private setters. So if you want to create an order, okay, you need to go through the constructor, or you need to go through a method on this class. You just can't new up an order class and start setting things like the ID or the total or the order date. Again, those need to be ran through the constructor in this case, or through a method to do that, because I want to apply all my business logic to make sure the values you're putting into these properties, are valid according to our business rules. So again, this is an example of using a more of a domain-driven design approach on this. So again, think about using a domain-driven design approach, domain entity, domain aggregate, when you have services that again have complex business logic, or when that business logic is changing frequently. Again, we're going to isolate everything. Each entity will have its own business logic and will have its own state. We're not spreading them across multiple classes. For simple classes that are more CRUD classes, like maybe our catalog service, again, probably the domain-driven design approach might be overkill. Keep these other ones simple until they need to be complicated. Okay, I hope that helps. Let's talk a little more about backing services. Again, this is a key area. So what is a backing service? When we're building out these I'm going to say cloud-native microservices, they depend on ancillary services. So I got my code, but guess what? It needs a relational database. It needs a document database, maybe it uses streaming. It needs a message broker. It has a dependency on a cache, security services, monitoring, storage services. So these external services, these are known as backing services when we're building an application. That's a term we see a lot when we're dealing with cloud-native microservices. So again, backing services. We want to treat these backing services as attached resources. That would be, if you look at the 12-factor application, that's a term they use. So basically we're saying we want to be able to attach, if this is my application, attach and detach my document database, my relational database, my cache. I don't want to be hard-coded to any of this or tightly coupled. This is to be loosely coupled. Again, so the goal is I want to have a plug-and-play approach, kind of a strategy pattern, where I can say, you know what, the application talks to a message broker, but it talks to some kind of abstraction in between, and that abstraction enables me to plug in different message brokers. I could maybe plug in here. I could begin to think about plugging in maybe Azure Service Bus. I could plug in possibly Azure Event Grid if that would make sense. If I'm on-prem, I could think about plugging in maybe RabbitMQ, one of the others. I don't want to be tightly coupled to Azure Service Bus or Azure Event Grid. That's not going to be a good scenario, pretty much. So again, the application should never directly reference databases, never, distributed caches, message brokers. All that should pretty much be behind some kind of abstraction shim. So so the application talks to the interface of the shim, not the service, right? And then when we start the application up, we can inject in the particular concrete instance of that particular, message broker, of that database, whatever we want to use pretty much. We want to isolate. We want to make sure that configuration too is isolated outside of the application itself. So again, here's an example of that. Let's look at here. So you can see in this application, again, everything, we talk to a message broker in here. These services send messages. We'll talk about that in the next module. But again, what they're using, with the message broker they talk to, we don't want to tightly couple to that because we may change that out. So we built an abstraction called an event bus, if you will. Event bus is pretty simple. It has two key interfaces. One is called an iEvent bus publisher, which exposes the publish method, and then we have an iEvent bus subscriber method as well too. So what this basically means is that when my application is talking to, a back-end event message broker, it talks to either the subscriber, the iEvent bus subscriber, or the iEvent publisher. Then what we do at startup, I'll show you an example here. What we do is we inject in what particular concrete message broker we want. So if we go here, we can see, if we, for example, were to go into the shopping basket Here is our startup class. You notice in the startup, we never have any references directly to in fact, you'll see the Redis these are grayed out. We have no references to banking services. We have an extension method we say register event bus publisher, register event bus subscriber, and in the extension method, if we go to extensions, you can see here, this is where we basically talk about, we're going to use Azure. This is where we talk about using a service bus in this case. So all of my specific references are here. So I can effectively plug and unplug different message brokers, different caches, so on and so forth. So again, we're abstracting it away. You can see we do this as well too with all of our data. I'm sure most of you have heard of and worked with the repository pattern. That's a key pattern as well too. We want to make sure that we don't have the application, the business object here, talking directly to a database. We could do that, it's easy to do, but then it's not always good. But then this business object is tightly coupled to whatever data store this is right here, which is not always going to be a good thing. So in this case, we can pretty much put some type of repository right into here, and the business object talks to the repository. It has no idea what in the repository talks to the database. So the business object does not know the data store. It knows to get data from the repository. You'll see that right here. My API talks to the business object. The business object needs data. It talks to the repository. The repository has plugged into it the exact data store we're going to use here. And what's nice about this pattern too is when I'm first building out a service, I might say, okay, I built my business object here. This is my service class, but I don't even have a data store yet. I'm not that far ahead. What if I build out a mock repository, and then I could put some mock data stores, and I can pretty much build out my service using mock data, and then when I'm good and ready, I can choose a data store, and I can build a repository for it, and I can plug that repository into my object. So again, the whole idea here is we want to make sure that when we're dealing with these ancillary banking services, databases, message brokers, caches, right, we want to make sure that we're not directly talking to them. We're always talking to some type of abstraction. You can see it here in the code. In the shopping basket, for example, we use Redis cache. You can see in the infrastructure, we've got a repository that abstracts Redis cache. So we could, at some point in time, unplug Redis cache and plug something else in. We would need to change the actual repository itself, but not the underlying code for that. Same thing here. If we go into the catalog, again here we're using, it also has in the infrastructure folder, it has a repository that we use for Azure SQL. We have the same thing if we go into ordering. We can see we have a repository. We have two here. We have one for our NoSQL Cosmos DB. We have repositories here. And we've got a repository as well too that abstracts away the fact that we're using SQL database for our writes. So again, that's a thoughts about building out backing services and about making sure that we don't talk directly to the service, but we're talking to some abstraction that hides or encapsulates the service. One more thought about this too, you might think about, when you're in the cloud, so back up to here, and you're using these managed banking services. Say, for example, you're in the cloud, and say you're running in Azure, and you're going to use, you could say, well, you know what, I'm going to use a message broker. I could say I want to use RabbitMQ. So I could provision a VM, and I could install RabbitMQ on a VM, and I could basically use that. Same with SQL Server. I could say, you know what, I'm going to use SQL Server in Azure. I could provision a VM. I could put SQL Server on it. The problem is this, though. When I do that, then I'm talking directly, then on that VM with SQL Server or on that VM with RabbitMQ, I'm responsible for managing that. Why not think about using a managed cloud service? Why not use Azure SQL Database, which is basically SQL Server running as a managed service in Azure? Why not use Azure Service Bus, which is a managed message broker that already runs in Azure? So instead of you provisioning a VM and installing either an open source product or say SQL Server on it, why not just use the managed service? chances are it's going to be less expensive, and you're not on the hook for managing and provisioning and managing that VM and managing that particular software. So again, we always, I think your recommendation is use managed services when you can. If you look at, for example, Azure Service Bus or Azure SQL Database, not only are they very robust, but they have security, they have identity, they have logging, they have scalability. There's a lot of stuff built into those managed services that you will not be responsible for. And they're supported by the cloud vendors. So if you have a problem with Service Bus or SQL Database, you can reach out to Azure for support. If you have RabbitMQ running on your VM in Azure and it breaks, guess who's supporting it? It's going to be you. Cloud vendors don't support open source open source software in the cloud. So again, I want to talk about one more thing. We'll take a short break again. Let's talk about observability. And again, this is really, really important. And when we first built out, so we have a workshop that we do for Microsoft customers. It is a 3-day workshop we do on microservices. It has labs. We have you building out microservices. The one thing that we didn't do up front is we didn't put monitoring or even in the bigger picture observability into it. We just let it go, right? And we found over time that that's not such a good idea. You really need from day one to put monitoring into your particular services. You need to collect, measure, and analyze. The traces, the logging, the event, the metric. You need a way to see what's going on inside the service, because when you're running these things, especially in a containerized, orchestrated environment, your logs are going to become key. You're not going to have such an easy time debugging into it. You're going to be looking at logs. So you really need to have a good logging, good monitoring in place, right? If you're in Azure, Application Insights is a very good solution. It is built into Azure. It's built into most of the Azure services. It gives you a robust view of data. Advanced logging, tracing metric, you can do a lot with it. A very popular framework we see used a lot is something called Serilog, as well as a monitoring framework. That can be also plugged in to Azure Application Insights. So again, we chose App Insights. It's a managed service from Azure, very feature-rich, easy to configure, tightly integrated. I'll show it to you real fast here if you haven't seen it. So again, if we go into Azure, let's go into Portal. Here's the Azure Portal. You've seen the Azure Portal. The Azure Portal is a dashboard that you can see all of your Azure stuff. I'm going to find everything that we do in this workshop, by the way, all of the backing services, the databases, the message brokers, the caches, everything's already in Azure. Even though we're running it locally, all the backing services are in Azure. Here is a resource group that contains it. You can see we have many Azure services here. We have a couple of SQL databases, a key vault for storing secrets. We have a container registry for storing images. Here's our Service Bus namespace that we have for messaging, our message broker. Here's a Redis cache. We have a couple of functions running in here. Here's our Cosmos DB. Here's Application Insights as well. If you open this up, again, the application is already wired. If I go into things like Application Map, I can get, actually, I haven't ran this for a while, but let me run it and I'll show you. We'll come back to it, and you'll see that you're getting very feature-rich. If we go to, let's see this, let's go overview. Let's go logs. I should be able to see from the last 24 hours in here. Let's look at logs. Again, I can run different queries in here. Lots of stuff going on. You can see lots and lots and lots of really good logging, lots of structured information in here. So again, what I found interesting, you may have heard of Sam Newman. If you haven't, Sam Newman is he's one of the original, he's been writing about microservices for a long time, considered definitely an industry expert. Look at Sam Newman. He's got this book, Building Microservices. I read an interview from him, and it said this. It said, if you're interested in adopting microservices, get your logging, in this case your log aggregation, before you do anything else, because without that logging, you're running stuff in Azure, you're running stuff in a containerized microservice, it's going to be very hard to see what's going on there. So again, the idea here is when you're running a microservice application, you need distributed tracing, distributed tracking, right? What does that mean? That means when a request comes into your application, it'll go through your front-end gateway, and then it will begin to go through your back-end services. You need to have some way to be able to say, I had a request, it invoked an operation in my microservice application, but some point in the process, I'm having a problem. I need to be able to aggregate all the different services together based upon that particular request and see exactly what happened. So again, you're going to want to generate a correlation token. For each request coming into the application, you're going to want to generate something called a correlation token, a unique value for that request. And that correlation token is going to follow that particular request all the way through from end to end for that operation. So you go through the gateway, you get your correlation token, you may go to service 1, the correlation token comes along with it, it's being passed, you go to service 2, back to service 1, to service 3, wherever you're going in there, you're passing the correlation token. Whenever you log anything, whether it's an informational logging, a warning, an error, you're always including the correlation token. That way, if I want to look at a particular request, if I know the correlation token value, I can aggregate my logs and I can filter my logs on that correlation token, and I can pretty much see the actual flow from end to end of that request. You're going to need that because you're going to be bouncing around from different services. You need some way to be able to see exactly where that particular request went, and you're going to probably want to also time the operations as well. So you want to see not only where it went, but how long that request was in each operation as well too. So you can kind of figure out where your bottlenecks are. So it's very important to, again, include a correlation token and make sure that as you're stepping through it, you have this distributed tracking. Azure's App Insights, it does give you that ability as well too out of the box. It can core, for example, we have in our application, we have each service talks to the same instance of Application Insight on here. So we're able to aggregate all the services into a single instance of Application Insights in Azure. And Azure does a really nice job too of being able to help us correlate those things together. So that becomes really, really key. So again, we talked about some architectural concerns. We talked about service, really service design. We talked about, when to use more of an anemic domain model versus when to use more of a domain-driven design model, how that comes into play. We talked a bit about backing services and making sure that the application itself is abstracted away from the backing services. And we talked a little bit too about observability. Key to have monitoring in there, and key to have, again, I'm going to use a bigger term, observability. Not only monitoring, but we need to actually be looking at the events, the traces, all of the diagnostics command, so we know what's going on with that service. We need to make sure that each request has a unique ID that gets passed along with that service so that we can filter on that ID so we can get the traceability of a particular operation from end to end across the application. So let's do a couple of questions, then we'll take a break, another 10-minute break. Jeff, are you available? Maybe not. Okay, well, in that case, let's just take a break right now. We'll take a short break. We're going to come back in 10 minutes. I will again put up a little timer here. Get some water, get some coffee, hit the restroom, get some fresh air. We're going to come back. I want to get into a really critical area, and that is going to be called communication. How do microservices talk to each other, and how do they talk to front-end clients? In the meantime, let's take our little 10-minute fiesta here. See you in a bit.